Welcome to the Angular Basics course with me, Todd Motto. In this course, you are going to learn the essential patterns and architecture for building your very own Angular applications whilst understanding the key principles of the framework. You'll uncover the benefits of things like one-way data flow, component architecture, immutable state practices, services and encapsulation, how to make things such as API requests via HTTP, and so much more, including modular architecture, and finally how to build a real-world Angular application from the ground up. Now, being a Google developer expert for Angular itself, I'm very excited and pleased that you've chosen to learn with me because I have so much knowledge to share with you. I've taught Angular to tens of thousands of students, from these online courses that you're taking just now, through to being on stage at conferences and teaching lots of workshops. Angular's goal is to allow developers such as yourself to build new web applications with less code in a lot less time. Angular also brought more traditional programming concepts, structures and patterns from server-side development to the web browser. Angular's roots go all the way back to 2009, where the project was first called AngularJS, and this was then considered the first version of the Angular that we use today. AngularJS and Angular are two very separate entities and projects despite sharing the same DNA. AngularJS was then officially released in 2010 after being taken on board by Google and has been built by a team of developers there ever since. Which then takes us to 2014, where at a European conference, the Angular team announced this new version of Angular under the name of Angular 2. Angular 2 was then under development for around 2 years and then officially launched in late 2016. Now, instead of being called Angular 2, Angular 3, Angular 4, as they switched to a new versioning syntax, the 2 was then dropped and the project was to be known as just Angular. Now, despite being called AngularJS and Angular, the two projects are far from the same. The two versions share common principles and concepts, yet they are vastly different. Many ideas from the old Angular were carried across to this new version of Angular, which we're going to learn. But the new Angular was entirely re-engineered to cater for the modern web platform and far beyond, thus bringing us to this big bang rewrite and this whole new version of Angular. This course is all about the new and improved Angular, and I'm extremely excited to take you through the latest of the platform. Angular is written in TypeScript, which is a project created and managed by Microsoft to bring static type benefits to our JavaScript code. TypeScript is essentially JavaScript with a few superpowers, so don't worry if you haven't used it yet. We're going to cover things as we continue. Alongside Angular, this helps us then write cleaner code, safer code, and it also helps us optimize our builds. Angular also makes use of a library known as RxJS, which means reactive extensions for JavaScript. Now, RxJS is a completely different paradigm. It's a bit more challenging. That said, there are some basic RxJS practices we can use within Angular that are very beginner and intermediate friendly. And of course, I will do my best to introduce you to all of these new concepts as we go through the course. Things such as observing when our routes or perhaps our data changes, RxJS allows us to then easily react and instantly reflect some of these changes. So that's the framework in terms of the languages and a high-level overview of the past, but how do we actually use it and what's inside? The Angular team recommends us to use the Angular CLI, the command line interface. The Angular CLI is a command line tool that we install, and we can then generate files and folders and talk to different modules, create components, and so much more. It packs a ton of sensible defaults to make our development lives easier. It does things such as compile, serves our project for us on a local host environment. It's also nice to not have to think so much about the build tooling side, so we can just focus on our project builds. The Angular CLI helps us build for production as well as our local host. Not only this, but the Angular CLI comes with some helpful commands to generate new files for our project, and it helps us to alleviate some of the boilerplate and manually wiring up our tasks. Time to talk about architecture. What makes up an Angular application? There are several main building blocks. We have modules, components, directives, pipes, services, and finally, the router. A module is a self-contained chunk of code that allows us to group related application logic. Our modules are typically standalone and often relate to features, which is sometimes why we use the term a feature module. Our feature modules can be absolutely anything, but typically are composed of major building blocks of our application. For instance, if we are building an admin dashboard, we'll likely have an admin module with all of our logic attached to it. This means that we could easily move it from application to application with ease. What's also great about modules is their ability to lazy load our code, which involves splitting our codebase into separate files and then requesting it on demand whilst we navigate through our application. The process of lazy loading helps optimize our application performance due to serving our smaller code bundles, which we'll come onto as we continue through the course. Next up are components. A component is a small unit of code that serves a single purpose. It usually takes our data and renders it to the DOM for our users to see or interact with, providing us with some independent UI functionality. When our application grows, many developers then struggle to keep their components clean and simple. And I'm here to show you some ways that we can think about your components and learn how to structure them with the correct mental models. This involves how we can make our components more composable and reusable, which are key concepts to succeeding with component architecture and scaling a codebase. Components can then render other components, and there are some very essential patterns you need to learn here when dealing with component communication. The core concept for us to master with component architecture is, in fact, understanding one-way data flow and the reasons behind it. Not only this, but learning the concept of application state and also this division with local component state. Turning now to directives. Directives do one of two things. They can add functionality to an existing HTML element or an Angular component, or they're in charge of rendering behavior, such as displaying a component conditionally or rendering it multiple times, such as rendering a list. Essentially, they take concepts or parts of JavaScript logic and allow us to then use them in our templates to provide specific functionality, which then gives us the capability to modify or generate new components or elements on the fly. Not only this, but Angular has built-in directives, which are then optimized for performance, ensuring that fast checking and rendering is taken care of for us. Angular also exposes various pieces of its internal directive APIs for us, so that we can then go and create our own custom directives. Directives are our gateway to the DOM. Should we need to provide some lower level functionality that requires tapping into the document object model, the directives is the place to do so, not inside the component. And this is a key differentiator between the thinking behind using a component or a directive. Which leads us onto pipes, another key aspect of Angular that can be thought of as just a simple pure function that transforms data for rendering inside of a template. Pipes are used inside of our component templates and are used in conjunction with data interpolation, which simply means that we transform the data we intend to bind before it's rendered. The idea behind a pipe is to simply hold reusable logic that we would then write over and over again. For example, let's assume that we are dealing with some dates. We don't want to keep writing the same date logic over and over. So we could turn to the Angular date pipe. We can then pass a date stamp and declare how we want to format it when it gets rendered. Inside this pipe is where the magic happens. We can then pass the date into a particular format and then send it back for rendering. The good news is that, much like a directive, there are not only built-in pipes, but we also have a public pipe API for us to create our own. And using pipes is a very common practice with Angular. So that's the data rendering and the UI side of Angular taken care of via components and directives and pipes. But the next step is to answer the question, how do we get the data? And this can be answered through services. Now, a service on its own is a generic class, and it can be used for almost anything, but it's mostly used for logic that is not component related. So try and keep that in mind. It's most commonly used for things such as data fetching, such as communicating over HTTP, perhaps WebSockets, and also we can hold pieces of application state in a service. Sometimes services are used for more than just getting the data. They can also be provided throughout our application. For example, we can safeguard a particular route by checking a permission, and this logic we can then contain in a service. So it doesn't necessarily need to be all about the data. It could provide some route checking functionality before we navigate to a different component. Now, the great thing about services is that services can be consumed by other services via means of dependency injection, known as DI in the Angular world. Services are also singleton classes, which means that they are instantiated once and their logic is then shared wherever it is injected. It's an important consideration when building our Angular applications to understand that we don't get a new instance of a service every time we request it in a service or perhaps a component. And this is actually by design and does make our lives easier. So finally, we land on the topic of routes and the concept of a router. In a traditional application, the routing logic would be handled on the server, and a page would be sent back to us when the browser requests a specific URL. This then comes along with a full page refresh, and a new page is then served to us. But, as we know, times have drastically changed, and JavaScript-driven applications are the new way that many of us like to accomplish our application builds. This means that the browser is now in charge of handling URL changes, which behind the scenes use things such as the History API. A router in Angular is an abstraction which essentially allows us to instruct Angular to render a particular component or a module based on the URL. We can then create more complex route segments that include things such as IDs to dynamically fetch data from a database, giving us a nice abstraction to read and write essential pieces of the URL. The Angular router also ships with some really nice built-in directives, which allows us to compose things such as navigation links, dealing with active states, and also navigate around our application when users do things such as click. We can then provide things such as advanced route information and parameters. Routes are also special as they bridge the gap between a specific URL and a component and its data. This means that we can intercept a route change. We can then do things such as preload data, we can check permissions, and so much more. These are all great topics for us to dig into as you continue your Angular journey. Routing is also the place where we go to think about things such as lazy loading, and we'll cover this as we continue. Let's wrap it up here and move on to learning more about Angular and component architecture. Here we'll dig a little deeper into learning about composing components, thinking about how we mentally design and construct them, understanding one-way data flow and the reasons behind it, as well as looking at things such as immutable data structures and why we should adopt the patterns. There is so much to learn, and I've designed this course to be as best as possible for you to really succeed with Angular. So with that in mind, let's get started.